All right, guys, I had a question on one of the multiple choice questions, and that's a good problem. It says a uniform solid cylinder made of lead has the same mass and the same length as a uniform solid cylinder made of wood. The rotational inertia of the lead cylinder compared to the wooden one is question mark. Now, of course, we see the right answer here is already less. But it has to do with the fact that if they have the same mass, but one's made out of lead and one's made out of wood, then they can't have the same size radius because of the densities of those two materials. So you might think about like the one with the smaller density, wood, would need a larger radius to have the same mass as a cylinder made out of lead. So you could conceptually think about that, which is very much like physics 1. If you want the mass version, here's kind of, or the math version, here's what I did this morning when I was kind of trying to put together something. So we know that the mass of the lead is equal to the mass of the wood. And we know that their lengths are the same, even though really that won't matter all that much. Well, I guess in terms of density, it matters a little bit. So what we really want to do is come up with an expression for the density of lead, which is mass over volume. And the volume of a cylinder would be like pi r lead squared, that's the circle, times the height, which I'm going to call L. I'd leave that alone. And then the density of the wood would be mass of the wood over pi, the radius of the wood squared times the length. Okay. So then I was trying to think, well, how would I prove this to somebody? We know the masses are the same. So what I'm going to do is solve both of these expressions for mass and then set them equal to each other. So I get the density of lead times pi, the radius of the lead cylinder squared times the length equals the density of the wood, pi, the radius of the wood squared times the length. Now I'll just do a tiny bit of algebra here. The pi's would cancel and the l's would cancel. And so I get density of lead times the radius of the lead disc squared is equal to the density of the wood times the radius of the wood squared. Well, if the density of the wood is small relative to the density of lead, then if these two expressions are equal, that means the radius of the lead cylinder would have to be small, and the radius of this one would have to be big. Now we're ready to go ahead and make our conclusion that if rotational inertia equals some version of mr squared, well, if both disks have the same mass, then the thing that would make a rotational inertia big or small would be the radius. And so the object with the larger radius would have the larger rotational inertia. And that's why that answer is correct. Hope that helps.